Welcome to this data-driven explainer. Today, we're diving into one of the most famous unsolved mysteries out there, but we're looking at it through a totally new, highly analytical lens. We're going to logically break down a really fascinating hypothesis by researcher, inventor, and author Kevin L. Brown. He proposes a map-based solution to the infamous shortcodes, specifically the Z13 and Z32 ciphers. So we're stripping away all the old rumors and just focusing on the math, the geometry, and the hard facts.
Okay, here's our game plan for today. First, we'll look at the short cipher problem. Then, we'll explore the map-based hypothesis, see how Z32 finds the location and how Z13 names the target. Finally, we're going to put this whole theory to the test with some strict scientific rigor.
Section 1. The short cipher problem, and exactly why the old models failed.
For decades, right, people just assumed these symbols operated like your standard secret code. One symbol equals one letter, eventually spelling out a human name. But Kevin L. Brown argues this is actually a massive mistake. His research shows that these codes are really a linked, map-based targeting system. They aren't meant to spell out a neat little sentence, they literally draw a line on a map.
And this right here perfectly illustrates why those text-only solutions always fail. The Z13 cipher only has 13 characters. In the world of code breaking, 13 characters is just way too short to solve using standard letter replacement. There simply isn't enough repeating data to establish a pattern. It's so short that you literally cannot solve it using math alone, unless, of course, you have an outside key to help unlock it.
Section 2. The map-based hypothesis and the geographic connection.
So the absolutely crucial point here is that these two ciphers are not independent puzzles, not at all. They are a split two-part system. The Z32 cipher acts as the positional vector. Basically, it tells you the where. Meanwhile, the Z13 cipher acts as the target identity. It tells you the what. This makes total sense of why neither puzzle works on its own. They're completely incomplete without each other.
Remember a minute ago when we said a short cipher needs an external key to be solved? Well, according to Brown, the author explicitly gave us the external keys we need to solve this mechanism. They literally sent a Phillips 66 roadmap. They referenced Mount Diablo. They gave direct instructions using terms like radians and inches, and even mentioned a clock face. These aren't just fun little decorative clues or random riddles. They're the actual, physical solve mechanisms required to decode the entire system. Section 3. Z32. Finding the location by building a physical map.
Instead of looking for a hidden message, Kevin L. Brown demonstrates that these 32 characters actually represent map angles and a physical distance. When the authors said to use a clock, they were practically shouting at us to use a clock face to turn these symbols into map directions. We're talking about a specific line shooting outward from a fixed starting point.
Now here is the missing variable. This is a thing that has tripped up so many people over the years: magnetic declination. See, the Earth's magnetic north actually moves over time. If you stood at Mount Diablo back in the year 1970, magnetic north was about 17 degrees different from true north. You absolutely have to apply a 17-degree correction for that shift, because otherwise, your line on the map just drifts off into total noise.
Following the math is actually super straightforward when you apply these 4 specific steps, essentially treating that clock instruction as your angular operator. First, you use Mount Diablo as your fixed origin point. Second, you adjust your angle by 17 degrees to account for that 1970 magnetic correction. Third, based on the Z32 translation, you project an angle of 4 radians, which by the way is roughly 246.2 degrees. And finally, you measure exactly 5 inches on that specific 1970 Phillips 66 map. To put that into perspective on that map scale, 5 inches equals right around 32 miles.
When you apply that exact math, it lands directly at these coordinates: 37.6935, negative 122.4497. This places the endpoint smack in the middle of the Ingleside and Southern Freeway corridor down in southwest San Francisco. By using the external keys exactly as we were instructed, we've established a highly specific, mathematically reproducible target zone.
Section 4. Z13. Naming the target or figuring out exactly what is at that endpoint. Now, the Z13 cipher famously begins with the text, "My name is," followed by 13 symbols. But this completely reframes how we look at the cipher. It's not a personal identity claim. The author wasn't saying, "Hey, here's my legal identity." The much stronger reading here is, "The name you seek is the name of the place." This turns those 13 symbols into a specific landmark label or a site descriptor at the exact San Francisco endpoint we just found. And this location in the Ingleside corridor isn't just some random patch of empty woods.
It perfectly matches the threat profile of a major public target. It's highly urban, it's visible, and it sits right next to major freeways and transit systems. It just fits perfectly with the kind of highly disruptive bomb threats the author was already known for.
Section 5. Testing the theory with actual scientific rigor.
Researcher Kevin L. Brown laid out a very strict field test protocol for this. And what that means is that any independent researcher, including you watching this explainer right now, can verify this geometry. You simply get your hands on a period-correct 1970 Phillips 66 map, use Mount Diablo as your origin, apply that 1970 magnetic declination, map out the radians and inches, and see for yourself if the lines converge on the Ingleside corridor. The data is completely transparent.
Furthermore, for any theory to be scientifically valid, there have to be clear ways to prove it wrong. And there are. If independent researchers do the math and the lines don't land in the Ingleside zone, the theory fails. If the endpoint lands out in the middle of the ocean, it fails. If someone proves Z13 is, in fact, a legal human name with zero ties to geography, the theory fails. Real science requires the possibility of failure, and this model completely embraces that.
Look, it is absolutely vital to separate fact from fiction here. We have to be crystal clear on the boundaries of this research. This explainer focuses purely on a narrow, highly testable geographic claim. We are claiming this is a positional cipher pointing to a map coordinate. We do not claim the author's personal identity is solved, and we certainly do not claim any device was actually found at this location. We're looking strictly at the Ala mechanism of the cipher itself.
This entire hypothesis really forces us to look at an incredibly old problem with fresh, data-driven eyes. And it leaves us with a pretty compelling thought. If this location-based theory is correct, and a notorious code was actually just a set of map coordinates all along, well, how many other historical puzzles have we been looking at entirely the wrong way? If a simple shift in perspective, from reading letters to drawing angles, can unlock a 50-year-old mystery, what else is hiding in plain sight? Thank you so much for joining me for this explainer. Keep questioning the data.